Today we'll discuss about proguanil. It's medicinal. We'll talk about the structure of the proguanil, mechanism of action, the IUPAC, SAR, synthesis, therapeutic uses, and etc. What etc? Simple. Our discussion will not be just limited to this video. We'll also discuss with you guys in the comment sections. Okay. So in the comment section, you drop your question as you drop your questions, and then I will come for the answers as I have the free time. Proguanil. So starting from the very first point, that is the structure of the proguanil. Structure is just in front of you, and just go through the structure and draw it. Well, I'm telling you guys the way how to draw in a very simple and easy way. I'm going to tell you guys the trick name. Now I will give this proguanil a trick name, of which you will be able to draw this proguanil in an easy way. Now what is that trick name? Trick name is proguanil chlorobenzene. Now by means of this trick name, you will draw the structure of the proguanil in an easy way. So first of all, let me tell you people about the trick name a little bit. Okay, so what is proguanil? Simple. Before moving through the entire discussions that is actually going to take place now, first of all, go through this trick name. Now, what is proguanil? What is chlorine? What is benzene? First, let me tell you about this. Proguanil is actually the combination of two terms. Is per my perception, you guys must split the entire terms, whatever you get here. So whatever the terms are available, split those terms and get your points, then go for the structure. So for proguanil, I will split this proguanil into two. First is pro, another is guanil. So for me, pro, and for us, okay, pro must be propyl. Got? We must consider pro as propyl. Then guanil must be considered as guanidine. And chloro must be considered as chloro. Benzene in the same is case with the benzene. So consider benzene as benzene. Now what is propyl? We know this point very well. When there are three carbons, we call this propyl. Guanidine. So guanidine is actually a little bit different, like a little bit different. This entire structure from this place to this place, nitrogen, carbon, nitrogen, carbon, nitrogen. This is actually the guanidine, okay? NCNCN. Three nitrogens having two carbon in between. So actually this is called as guanidine. Okay, this portion is guanidine. This portion is actually guanidine. And some guys are considering it just like the half portion guanidine. Half is not the guanidine, complete is guanidine. Okay, well, this is actually the guanidine. When there is such kind of interactions between the nitrogen and carbon, this is actually guanidine. Nitrogen, carbon, nitrogen. Then here like this is guanidine. So clue to remember guanidine is simple. Must be having nitrogen, then carbon, then nitrogen, then carbon, then nitrogen. Three nitrogens, two carbons. That's it. So then wherever you find the carbon, with that carbon just draw two bonds. And with that, just draw NH2. Not NH2, just NH. Because valency will become somehow more than three for the nitrogen. And we know that carbon is having 1, 2, 3, 4 bonds. It's supposed to form 4 bonds. Nitrogen is supposed to form 3 bonds. Well, now coming towards the chloro, we know about the chloro, and benzene, we know about the benzene. Chloro and benzene, easy ones. Now, you got the structure, you got the names, so and then the structures also. Okay, so now we got the entire trick name. Now from this trick name, we'll draw the structure. First of all, I gave you the briefing of the trick name. Now let's go towards the drawing. Proguanil chlorobenzene. Pro, I told you it is what? Propyl. Draw propyl here. And then we have guanil, means guanidine. Guanidine is actually having nitrogen with that carbon, then another nitrogen, 1, 2, second nitrogen, third nitrogen, having 2 carbon between. With every carbon, just have 2 bonds. With that, just have this kind of attachment, that is of nitrogen and hydrogen. Got? Very simple. So then we got the remaining portion, that is pro is then propyl, guanil is guanidine, chlorobenzene. Simple. Chlorobenzene should be always this way in the medicinal. So here is our structure being drawn. We got the entire structure in a very easy way. By mean of what? By mean of the trick name. Chlorobenzene is in front of us. Then we have guanidine, and here we have propyl. Propyl, guanidine, chlorobenzene. So from now onwards, stop calling proguanil just proguanil. Call it as proguanil chlorobenzene, because it's easy to get the structure then. Because it's easy to get the structure then. Yeah. So we got the structure now. Now let's come towards the mechanism of action. Well, before moving through the mechanism of action, let me tell you people about the pathway. Now, this pathway is actually for the purine and pyrimidine synthesis, and you guys must know that purine and pyrimidines are actually responsible for the synthesis of the DNA and RNA. Well, so now how this purine and pyrimidine is actually synthesized, or how these are actually synthesized. Let's go through the pathway. And if we get the pathway, then I will tell you people about the mechanism of action of the proguanil. Well, pathway is just simple. When PABA interacts with the tyrosine by means of an enzyme known as dihydrotyrosine synthase, it will synthesize dihydrotyronic acid. Then on that, there will be another enzyme interacting known as dihydrofolate synthase. Dihydrofolate synthase will synthesize dihydrofolic acid. Then with that, another enzyme, dihydrofolate reductase, will be having kind of interaction, due to which then there will be the synthesis of tetrahydrofolate or folic acid in short. So folic acid will be synthesized through this pathway. That folic acid is actually a cofactor responsible to undergo some processes and to at the end provide us purines and pyrimidines. So these are must. Folic acid is must as a cofactor. So when the folic acid is not available, there won't be the purines and pyrimidines available. So anywhere, whenever, anywhere in the entire pathway, you just stop a portion, you are actually inhibiting the synthesis of DNA. In short, okay. So what we got now, proguanil. This will come and this will interact with this enzyme, dihydrofolate reductase. When this enzyme is having a kind of interaction with this proguanil, then what will happen? This will be actually a kind of inhibited, due to which there won't be synthesis of the folic acid. And we got the entire discussion. If there is no folic acid, then there is no purine, no pyrimidine. In short, there is no DNA. So this is how proguanil is actually destroying or inhibiting the synthesis of the DNA of Plasmodium. Hope you got the discussion. Well, before moving towards the IUPAC SAR synthesis and therapeutic uses, guys, go through this. +92 340 80 60081. Here you will find the remaining lecture. Contact us. Well, now what to do? The remaining lecture should, yeah. Now let's move towards the remaining discussion. That's of IUPAC. For the IUPAC, I'm supposed to raise this portion. لا إله إلا الله محمد رسول الله أشهد أن لا إله إلا الله وحده لا شريك له وأشهد أن محمدا عبده ورسوله لا إله إلا الله محمد رسول الله